Hey everyone, moving on to the first example of our vectors, which is basically exploring the basic properties. We have this figure ABCD, and we have the following three vectors. Vector AB is 1, 4, so what I like to do is, well, write down the vectors on the figure. So make sure the arrow is in the right direction, so going from A to B, the arrow should be pointing towards B. So vector AB is 1, 4, vector CB, so be careful, it is C to B, so it should be going leftwards. Minus 3, 1. And then AD is 5 minus 2. Find the three vectors AC, DC, and BD. So let's do AC first. So vector AC is kind of like going from point A to point B and then towards point C. Alright, so that's one way to do it. Of course, there are other ways to do it, but that's the easiest one we can do it thus far. So A to C is simply AB to BC. So we have 1, 4. And because we want, or rather I should actually show it out step by step. Alright, so we want AB and then vector BC. But we only have vector CB. So what we can do is, for AB we know is 1 over 1, 4. And then BC we know that is simply minus of the vector CB. Alright, so it's very simply 1, 4 minus 3, 1. So 1 minus 3 is 4, 4 minus 1 is 3. Alright, so first vector done. Next vector, vector DC. Alright, so vector DC, well, you can think of it as going from D to A to B, and then B to C. So always remember the connecting points are the same. Of course, if from here, let's say you have a parallel line, which I'll be talking about in the next video, then you can substitute them. But for now, or whatever it is for addition, the connecting points must be the same. So DA again is minus AD, so minus 5 minus 2. AB is AB, so 1 over 1, 4, and then BC, well, very simply, minus 3, 1. Of course, there's another way to do it. If you were to trust your answers in the first part, it's simply DA plus AC. But nonetheless, let's just do it this way and keep that in mind. So minus 5 plus 4 is simply minus 1. 2 plus 3 is 5. Alright. So this is the first two vectors. The third vector, BD. Okay, so vector BD, you can think of it as going from B to A and then A to D. Another way to do it is simply using the identity, right? We have either identity where if we have one vector with 2 points, so let's say we have xy, vector xy is simply a common point of the second point, or rather the position vector of the second point, and then, well, not really position vector, it's a common point to the second point, and then another common point to the first point. Alright, so the second point first, and then the first point. And you notice that they'll share a common point, either O, A, or whatsoever. So we can kind of use that idea here. Alright, so we have BD, and we notice that we have vector AB and vector AD, right? So we have the common point A, and then D and B are individually down there. So we essentially have AD minus AB, alright, equals to AD we know is 5 minus 2, minus AB minus 1, and minus 1, 4. 5 minus 1 is 4, minus 2 minus 4 is simply minus 6. And we can actually easily prove this, right? We know that minus AB is equals to BA. Alright, so we have this equals to, let me just write that down properly, vector AD plus vector BA, and then we can do some switcheroo and we have BA plus AD, and of course this thing gives back vector BD. Alright, so there we have it, a very simple example of addition. I don't think I'll ever rather finding vectors involving addition, subtraction, and some nice properties, the xy equals to oy minus ox. Of course, I will be going through the modulus here. I think it's quite simple. Let's say we take the example of vector AC is simply the square root of 4 square plus 3 square, which is 16 plus 9 is 25, so it's simply 5. Alright, and I think you can solve the rest on your own. So that's the end of the first example.